Hello, and welcome to Module 2.2, Solving One-Step Equations. Our objective for this lesson is that I can solve equations by using addition and subtraction, and I can solve equations by using multiplication and division. So what does it mean to solve an equation? What we are looking for is all values of the variable that make the equation true. All right, so all values. Early on here, we're going to look at singular equations. We're going to look for one specific value. As we move forward, when we do inequalities, there could be a number of solutions to an inequality. And if we start talking about systems, again, we go back to one specific point again. So a solution, what is a solution? It is each value that makes an equation true. Okay, each value, meaning there could be more than one that would make an equation true. So that is our important piece. We're going to test to make sure equations are true. And equivalent equations are different equations that have the same solutions. And I'm going to really emphasize that same solutions. So for example, let's draw in something that could be some equivalent equations, right? You could have x, so let's do 3x equals 9, and you could have x equals 3. Those are both showing the exact same relationship. They are equivalent equations. Now, let's talk about a couple of the properties that we're going to be using. There's the addition property of equality. This says that if a number is added to each side of a true equation, the resulting equivalent equation is also true. So if we have, for example, x minus 5 is equal to 5, and we add 5 to both sides of the equation, we get x is equal to 10. Right? We have changed the look of this equation, but because we did the same operation on both sides of the equal sign, we are still equivalent, meaning that this is a simplified version of the equation that we started with. Now, the subtraction property of equality is simply the mirror of the addition property of equality. So, if we have x plus 5 is equal to 10, and we subtract that 5 from both sides, we'll get x is equal to 5, right? We did the same operation on both sides of the equal sign, so that means we are altering both sides of the equation in the exact same way. And by doing so, we've actually simplified it and found our solution. The multiplication property of equality. Right now, you're probably figuring this out. You know we're going to be multiplying. So if we start with x over 3 is equal to 12, for example, this is an equation that we know is true because we're given it. And we multiply by both sides by the same non-zero value, we can get an equivalent expression. So if we multiply both sides by 3, for example, we're going to get the equivalent expression that x is going to be equal to 36. Right? We multiply both sides of the equation by the exact same amount, and our 3's cancel out, and we're left with x on the left side. So this is how we go about solving equations. We work with opposite operations. Now, the division property of equality, again, same exact thing. If you are doing the same operation, division on both sides of the equal sign, then the resulting equivalent expression is true. It is equivalent. So if we have 3x is equal to 6, and we divide both sides by 2, we get that we divide both sides by 3, we get that x is equal to 2. So let's work our way through some examples. Example 1 and 2 are combined here, and we're going to solve using addition or subtraction. So when I look at this, I am always looking to do whatever the opposite operation is of what I see. So right here, I am seeing that we are subtracting 25. So if I want to isolate the variable, I want to get the variable, this, all by itself, what do I need to do? I'm going to do the opposite of what I see. I'm going to add 25 to cancel it out. And when I do, we have G is equal to 113 plus 25 is 138, right? So by adding 25, we went to that additive inverse again, properties from module 1 that we are going to be using all year long. We added 25 because it's the additive inverse, which means they add up to 0, they cancel out. So we've done the same thing on both sides, and we now know that G is equal to 138. Letter 27, or number that. Letter B is 27 plus K equals 30. Now, on this one, we have our coefficient out in front of the variable. And it's important to notice, whenever we have a coefficient or wherever it is, we always want to look at what's in front of it. In this case, there is no number in front of it. There's no sign in front of it. So we know that this is positive. So the opposite of a positive 27, its additive inverse would be a negative 27 from both sides. And when we do that, we get that K is equal to 3. 30 minus 27 equals 3. Notice how I'm working vertically down the page. This is how I would expect you to be showing your work in class this year. Letter C. We have 2/3 plus W is equal to 3/2. Ooh, this isn't very nice. So we need to find, we know fractions. Fractions are our friends. So we need to find an equivalent fraction that we would be able to work with. All right. So I know that 2 and 3, their denominators, you know, we can't get 3 to be 2. We can't get 2 to be 3. So then we need to go to our least common multiple. And so that's the lowest common multiple that both terms have, a 3 and a 2. And in this case, it would be 6. So I'm going to rewrite this. And we're doing maybe a little more than 2 steps here, or 1 step here. So if we convert this fraction to 6, we're going to multiply by 2 over 2. That's the multiplication property of equality. We are multiplying by the same thing, right? So 2 times 2 is 4. 2 times 3 is 6, okay? We have plus W is equal to, this one is going to be multiplied by 3 over 3. So 3 times 3 is 9 over 2 times 3 is 6. Now we can do our subtraction. So we're going to subtract 4/6 from both sides. And we get that W is equal to 9 minus 4 is 5/6. If you don't remember, when we have a common denominator, we subtract or add the numerators and we keep our common denominator. And as always, when we're dealing with fractions, we need to look and see, is this something that I can simplify? 5 over 6 is not something that can be simplified. There's no common terms there. All right. So let's look at letter D. We have 8.6 plus y equals 17.8. So again, we can just use the addition property of equality and subtraction property of equality. And we are subtracting 8.6 from both sides of our equation. Again, notice I'm drawing this line to show each of my steps is happening here. And when I go ahead and do this, 8.6 minus 8.6 is 0, so that cancels out. And we've got y is equal to 17.8 minus 8.6, and you're going to get 9.2. So these rules even work with decimals. All right, letter E. We have -6 plus x equals 21. Now, I wanted to use this one very specifically because of that negative sign there. What is the opposite of a -6? It's going to be +6. So we need to add 6 to both sides as our opposite operation. And we get x is equal to 21 plus 6 is 27. And our 6's cancel out. -6 plus 6 is 0. They go away, right? And I specifically chose this one because there's an addition sign there. Because that's something that people would trip up. They would see the addition sign and assume, oh, well, we're doing the opposite of adding, so we need to subtract. No, 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 no. You need to look at the sign that is in front of whatever piece you are working with. In this case, you have a negative sign in front of the 6, So that tells us that the opposite of whatever's happening there is going to be to add a positive 6. All right, letter F. We've got x minus 9 is equal to 27, so opposite operations. We add 9 to both sides. X is equal to 36. All right, so there are 3 you-try problems, G, H, and I. I would like you to do those 3 on your own now. Come back and check your work when you are finished. All right. For letter G, we're going to start off with, this is just like what we saw in example E in the previous row. So we are going to do the opposite of what we see. So the opposite of negative 8 is plus 8. All right, we do that to both sides of our equation. And we've got negative 8 plus 8 cancel out, and we're left with 6 is equal to 20. Sorry, x is equal to 20. Letter H. We have a plus 12 on the left side, so we're going to subtract 12 from both sides of our equation. We get that y is equal to negative 12 minus 12 more. We're going further and further to the negative, is minus 24. All right, letter I. We've got fractions again, but thankfully this time we have common denominators. We are subtracting 3/4 from both sides. Subtract 3/4 from both sides, and we get that y is equal to negative 2/4. And as I look at that, I know 2 over 4 is going to reduce, so it's going to be y is equal to negative 1/2. All right. So let's take a look. We're going to look at example 3, which is write a one-step equation. In tennis, the Grand Slam tournaments are the 4 most prestigious annual events. At one point in his career, Roger Federer had won 3 more Grand Slam singles titles than Rafael Nadal. If at that time Roger Federer held the record for the most Grand Slam single titles won with 17, how many Grand Slam single titles had Rafael Nadal won at that point? So let's start by putting this into words. So we know that we were told here that Nadal, right? So Federer has won 3 more Grand Slam singles titles than Nadal. So we start off with Nadal plus 3 titles is, well, what's our total? Our total is 17. Or, well, it is what Federer has, okay? And we already know that this is going to be 17. So let's define our variable then. So we're going to say n is equal to Nadal wins. Okay, n is Nadal wins. And so if we write our equation, we have Nadal wins plus 3 is Federer, which is 17. So if we look again, Roger Federer has won 3 more Grand Slam singles titles than Nadal. So we have 3 singles titles more than Nadal is 17. Okay. And it asks us how many Grand Slam titles. So now that we have the equation, we're going to subtract 3 from both sides, and we get that n is going to be equal to 14. Sorry, not subtract 3. Yes, subtract 3. And Nadal at that time had 14 titles. Okay, Nadal has 14 titles at this point in time, compared with Roger Federer's 17. 2 of the greatest all-time men's tennis players that there are. All right, I want you guys to do letter B on your own and then come back and try it against mine. So on average, a male bulldog weighs 15 pounds less than a male golden retriever. If the average male bulldog weighs 50 pounds, write and solve an equation to find the average weight of a golden retriever that's male. So let's put it in words. So if we've got a golden and it is 15 pounds less, okay, so minus 15 is a bulldog. So the bulldog is 15 pounds less than a golden. So golden minus 15 is a bulldog. All right. So we were told average bulldog is going to be 50 pounds. So let's do our variable. G is going to be our weight of a golden. All right. And we know the bulldog's weight is going to be 50 pounds. So that is going to be 50. So if we go ahead and write our equation, our golden minus 15 pounds is our bulldog, which is 50. And now if we want to go ahead and solve this, we add 15 to both sides, and we find out that the golden is going to be equal to 65 pounds, LBS. All right. So male bulldog weighs 15 less than a golden retriever. Golden is 65. Male bulldog is going to be 50. All right, we're going to move on to our next page here in these very long notes. So example 4 is going to be solving these using division or multiplication. So starting off, we have negative 14y is equal to 42. So to divide out, we're going to divide by negative 14 on both sides. Again, I am showing all of my work. So now we've got negative 3 is equal to y. 42 divided by negative 14 gives me negative 3. A positive divided by a negative is negative. All right, letter B. We've got 6y is equal to 54. We're going to divide both sides by 6 because we're trying to get that y by itself. We get y is equal to 54 divided by 6 is 9. All right. Letter C. This one is tricky. It's a little weird at its first look. We've got 3/8 x. Well, okay, I could divide by 3/8, but if I think back to 6th and 7th grade math, I know that if I am dividing by a fraction, that is equivalent to multiplying by its reciprocal. And reciprocal is just flipping the fraction upside down. So we're going to multiply the left side by 8 over 3, and we're going to multiply the right side by 8 over 3. Now, how does this work? Why does this work? If we look real quickly, we've got, think of a fraction as 3 divided by 8, correct? So if we're dividing by 8, well, the opposite of dividing by 8 is to multiply by 8, okay? And the opposite of multiplying by 3 is to divide by 3. So this is why this multiplying by the reciprocal works, because we are doing the opposite operations here. We're just doing it in one step instead of doing them separately. So I know when I do this and I take a look at it, right, our 8s cancel, our 3s cancel, so I'm going to be left with x on the left is equal to, when I multiply fractions, we multiply straight across the numerator. So we're going to do 9 times 8, which is going to give me 72. And we multiply straight across the denominator. 4 times 3 gives me 12. So the last thing I want to check is to make sure that I can reduce my fraction if possible. 72 over 12 divided out gives me a value of 6. Now, could we have gone at this and seen that 8 and 4, this can be reduced to 2 and 1. And 9 and 3 can be reduced to 1 and 3. 3 times 2 is 6. 1 times 1 is 1. So when we're looking at these fractions, we're treating them as one big fraction with pieces multiplied in the numerator and denominator, and we can simplify that way. All right. Let's look at letter D. We have y over 2 is equal to 15. So the first thing I want to do, I want to get that y by itself. So we're going to multiply by 2. So I multiply both sides by 2. Y is equal to 15 times 2 is 30. All right, letter E. We have 3/4 x equals 6. This is another prime time for us to be using that multiplying by a reciprocal idea. Okay, so we put parentheses and we do 4/3 and 4/3 on both sides of our equation. So our left side cancels out. I'm left with just x because 4 times 3 is 12. 3 times 4 is 12. 12 divided by 12 is 1. So we have x is equal to 6 times 4 is 24 over 3. And then when I simplify that, 24 divided by 3 is going to give me simply 8. All right, letter F. 22 is equal to 4m. So I'm going to go ahead and divide both sides of my equation by 4. And I get 11 over 2 when I reduce that is equal to m. And I reduce that just because I could divide the numerator and denominator both by 2. So it's 11 over 2m. Okay. All right. Now, I want you guys to try letters G, H, and I on your own, and then let's go over them together. Letter G. Again, we have a fraction here, so we're going to work with the reciprocal. It does not matter that your term that you're isolating is on the right side this time. We're going to do the same steps. We have 7 over 5 on both sides. So we get that y is equal to 350 over 5, right? 7 times 550 is 350 divided by 5. And then when I simplify that fraction, y is simply going to be equal to 70. And I could look at that at the original. Well, 50 divided by 5 is 10. 10 times 7 is 70. So you can do some of that math in your head as you go and simplify a little bit. That is helpful to you. All right, letter H. We have 8x is equal to 32. We're going to divide both sides of my equation by 8, and we get that x is equal to 4. And letter I, we have y over 8 is equal to 1/4. So we have a fraction. We don't really need to multiply by the reciprocal, although truly we are, because we're multiplying by 8 right here and right here. But you could also think of it as being 8 over 1 and 8 over 1, because any coefficient is, or a constant is a number over 1. So my 8's cancel on the left. We've got y is equal to 8 over 4. Well, 8/4 simply reduces to 2. 8 divided by 4 is 2. All right. Well, now we've got to solve a word problem by multiplying. So we've got Kenji, and he is going to take a survey of the sophomore class. If 96 sophomores, or 2/3 of the class, said they were going to go to the football game on Saturday, how many sophomores were in the survey? So we need to know, we're trying to figure out how many sophomores. So x is going to be equal to sophomores. All right, so that's our number of sophomores. And I know that 2/3 of the class said they were going to the football game. So 2/3 times the number of sophomores is going to the football game. And that 2/3 equals 96. So 2/3 of the entire class is 96. So now we need to solve this. We're going to go ahead and we are going to multiply by our reciprocal. So we multiply by 3 over 2, multiply by 3 over 2, and we get that x is equal to 288 over 2, which when we simplify is going to be x equals 144 sophomores. Okay, so that's how many sophomores were surveyed. Okay. I want you to try the problem on the next page involving Imani. Imani is making costumes for a play, and she spent $146.58 on 21 yards of fabric. Write and solve an equation to find how much Imani paid for each yard of fabric. Fabric is measured by length, distances measured in a yard. So try this on your own, then come back and check your work against mine. So we want to know how much Imani paid for each yard. So how much for each yard of fabric? So C is going to be our cost per yard. And oftentimes you're going to see me write instead of writing the word out, cost per yard, cost divided by yard. I'm going to just do that slash to tell us we're doing division. So cost per yard is what C is going to represent. So I know that I have 21 yards of fabric that she bought. So 21 times the cost is going to be equal to our $146.58. So now I need to solve for C. So I'm going to divide both sides of my equation by 21 to get cost by itself. And so cost is equal to 146.58 divided by 21. I am not expecting you to do that in your head. You are going to use a calculator for that. You get 6.98, and we are going to put a dollar sign in front per yard. So the cost of the fabric was $6.98 a yard, somewhat on the expensive side, but not absurdly so. All right. So that is the end of our notes for Module 2. If you have any questions, please make sure you bring them to class when I see you. Have a great day.